So assignment D is on probabilities. Okay, numbers 1 to 5. Please attempt them independently because they are more or less definitions. Okay. What is probabilities and events? What are these? Okay. Number 2, number 3, number 4, up to number 5. Now, from number 6, that's where calculation starts. That's where analysis begins. Okay. Yep. Now, the analysis part of probabilities was divided into 4 categories, 4 sections, if you will, okay, or 4 subtopics. Number 6 comes under discrete probability distribution for analysis, okay, discrete probability distributions, page 7 in the weekly notes, number 10. So if you go to page 7, you will get examples, you get explanations with regards to the discrete probability distribution. Here it is. Here it starts. And here's an example 10.3. Discrete probability model. And you have an example 10.3. Here it is, page 7. Example and solution. So as you can see, it resembles closely number 6. And I took the liberty to write the heading for that subtopic, discrete probability analysis. Okay, so that's where we'll begin demonstrating. Then you have the algebraic approach. So from number 7, number 8, number 9, and number 10 comes under the subtopic algebraic approach to probability analysis. You can get that on page 4. So if you go to the week 10 on page 4, there's an example of how to solve a question like that. Okay, and it would be good to look at the video that was previously made. Okay, here they are. We must make use of those formulas. Okay, algebraic probability analysis, here it is. So here are examples very similar to number 7, 8, 9, and 10, as you can see. Okay. Then we move on to number 11. Number 11 comes under the subcategory of contingency table for probability analysis. You can get that in page 5 or 6. Contingency table, here it is, for probability analysis involving one selection. And you are familiar with this table for the chi-square test for independence. Is a contingency table. Okay, you have 2 variables. Here you have gender and your dominant hand, you know, your dexterity in this example. The contingency table. In the assignment is your score and your major. Okay, these are the 2 variables. How does your major affect your score? And then the fourth subtopic is the tree diagram for probability analysis. You can get that from page 11 to 17 in the week 10, the tree diagram. So here you have the tree diagram for probability analysis. Okay, so we started with number 6. Okay, so I sent a video with regards to, what is probabilities, and introduction to the word probabilities and so forth. So take a look at it. All right. So we started with number 6, how to approach a question like number 6. It comes under the topic of discrete probability analysis. All right. Here you have a table called a discrete probability distribution. Okay. And the first question says determine the value of A. That should be determine the value of B, because I changed A to B. The assignment of A, I changed A to B in the worksheet, so I supposed to change this to B. Find the value of B. Okay. Assistance is in week 10, page 7. So when we go in week 10, page 7, here it is, the discrete probability distribution. Let's see what there we can use to help us find the value of B. It reads, discrete probability model or distributions, quantitative discrete data. It can simply be put as a probability model, as probability models for numerical discrete values. You have some key points. So discrete probability distributions are numerical probability models for random variables. The variable has a finite or countable number of values. A random variable is a numerical variable whose value depends on chance. Okay. So this is just some reading. We'll see how important it is, or not really important it is. We'll only be dealing with discrete random variables. Random variables are denoted by capital letters, and discrete random variables have distinct values, 1, 2, 3, 4, 5, 6, and so forth. So that's why these values will be always whole numbers, and the probability values must add up to 1. So the probability values must add up to 1. So this is a key point in a discrete probability distribution. It comes with a set of whole numbers and probability values. And very importantly, as it is written here, the probability values must add up to 1. So please take note of that. Let's carry it forward. Very key point when you see a table like this. So for solution for part A, let's bring this forward. The probability values must add up to 1. Okay, symbolically, this is words. These are words. The probability values in a probability distribution must add up to 1. Okay, so basically, symbolically, this is written as the sum of the probability values must equal 1. Okay, the sum of the probability values must add up to 1. So therefore, B plus 0.25 plus 0.036 plus 0.17 plus 0.12 must equal to 1. Okay, so again, it says determine the value of B. B is a probability value. The rule is that the probability values must add up to 1. Symbolically, the total of P is equal to 1. The total of P means you have to add up all the P values, and this must give you 1. So therefore, now we are in an equation with B in it, and we can use this equation to solve for B. So we find the total of the existing probability values. I repeat, we find the total of the existing probability values from 0.25 to 0.12. We get 0.576, 0.576, and we can simply subtract 0.576 from 1, and this will give us the value of B. .424. So this is what you do for number 6 in assignment D. It says find the value of E. Okay, and you have some existing probability values. You can easily find the value of A by using the rule whereby the probability values must add up to 1. Okay, in a discrete probability distribution.